Today I'm presenting on our project Camera Adversaria, which is a mobile application which uses procedural noise to filter a user's photographs such that they are more resistant to deep learning-based systems of surveillance. This is work done in collaboration with Ben Swift of the Code, Creativity and Culture Studio at the Australian National University, and also Terhi Nurmikko-Fuller of the Centre for Digital Humanities Research, also at the Australian National University. When we think of surveillance, usually we think of metaphors like Orwell's Big Brother and Foucault's Panopticon. And these two metaphors also dominate the academic theorizing of surveillance. Both focus on totalizing systems and the state, and so they tend not to be ideal metaphors for describing non-state surveillance. This paper is particularly interested in surveillance, oriented by economic power rather than discipline and punishment. And so there have been a number of attempts to describe this phenomenon, but this paper takes its theoretical point of departure from Shoshana Zuboff's surveillance capitalism. Zuboff describes surveillance capitalism in her book published last year, not as a technology itself, but rather the logic that imbues technology and commands it into action, particularly the economic logic. So the point is that technological development is not a kind of natural deterministic process, but rather it's largely oriented by economics and profit making. And this is a similar argument to that made by Max Weber. So to understand this kind of surveillance, we need to understand it in a broader context of economic relations. The challenge this presents is that we're dealing with extreme asymmetries of knowledge when it comes to these systems. If you haven't seen it before, I want to point to Anatomy of an AI System by Kate Crawford and Vladan Jola. This is a large-scale design project that attempts to reveal the extremely complex economic, social, technological networks that are required for Amazon's Echo to function. And this includes everything from mining operations to AI, through to networks, through to end-of-life processes for these devices. The project has slightly different aims, but in terms of what exists, this is the best picture that we can start with as a model for systems of corporate surveillance, and particularly today's models, which really are powered by deep learning and what is sometimes called artificial intelligence. So there are two things I want to draw your attention to with regards to this image. First is just how brittle this system is, and that we as users only touch a tiny fraction of the broader system. I also want to note that most of this network is still a collection of human relations, and there may be scope in HCI for us to consider these interactions that are beyond the confines of use, which we normally consider. Given that we can only touch a tiny fraction of the system that enables surveillance capitalism, what can we do in this space to give some power back to the subjects of surveillance capitalism? So we want to treat this as a design problem, and particularly we're adopting a methodology of critical design. Critical design is critical in the sense of critical theory of the Frankfurt School. It comes from theorists Dunn and Rabi, who worked primarily in industrial design, but it's been adopted also in HCI as a research through design methodology that foregrounds the ethics of design practice. So particularly our project is concerned with photographic surveillance and how that is consumed by technology companies. This Anatomy of an AI System does a good job of revealing the scale of these networks, but in general I think we're dealing with an extremely information-limited scenario where the way that this system operates, it tends to be entirely unknown to end users. Mobile computing devices have totally revolutionized personal photography. So we've been taking photos at a much higher rate for decades now, and these photographs have been accreting in social media databases. But for a long time, the tech really didn't exist to interpret these images beyond what you could convince a user to describe in them. And all of this has changed with deep neural networks. Deep learning has totally revolutionized computer vision and really made a semantic interpretation of images a possibility at scale. What we're really talking about in terms of this semantic image classification is often a system which, for our purposes, we can treat as a black box that takes an image in pixel data and returns prediction values for a series of labels. So deep learning activated the economic value of large databases of users' photographs. One example of how this has occurred is work by Jeff Hinton's lab at the University of Toronto, which was purchased by Google and moved into production in just a little over 6 months, according to the Google research blog. And so it's clear from that kind of statement just how economically valuable this technology was and is to tech companies. The other thing that I want to talk about is the camera itself is becoming a surveillance device in a more literal sense. So in another article posted by Google's research blog in December, They confirmed that a future direction was the inclusion of deep learning within the camera app itself. So if you care about privacy, this should be setting off some alarm bells. Privacy work in HCI has focused so far on redactive methods, and by that I mean taking visual information out of a photograph, whether it's by blurring or covering it up or camouflaging or even generating things to sit over the top. Bizarrely, even cryptographic methods, and certainly blurring and pixelation, appear to not affect deep learning-based machine vision in the same way that they affect human vision. And so for all the talk of machine vision, human vision and machine vision have fundamentally different capacities, and this is a recurring theme of this paper. So I think one of the things that we're missing in the HCI discourse is a kind of question of privacy with regards to whom. And so redactive methods disrupt human vision, but what if we want to maintain the social function of images? What if we still want to share images online, but we just don't want to be subject to this kind of additional system of surveillance? And so we need divergent privacy practices when we require privacy with respect to humans and machines. So as surveillance systems have grown, so has resistance to these systems. And particularly, I want to talk briefly about the work that's happened in the art and design community. This is a project CV Dazzle by Adam Harvey, where makeup and hair design are used to disrupt the standard facial recognition algorithm. Another work in a similar vein is You Are Me by Leo Salvaggio. And in this work, Salvaggio would sell very high-resolution masks of his own face and allow people to walk around potentially surveilled areas and adopt his facial features. And this had the effect both of allowing others to pass undetected in his identity, but also it introduces noise into his own surveillance trace. I also want to point out that I think we can consider the redactive methods that we see in HCR research as being equivalent to camouflage post hoc. So we're still obscuring the face in some way. Another mode of resistance is what I'll call avoidance. This is a project I see by the Institute of Applied Autonomy, where they created a mapping application that would lead you from point A to point B by taking the path of least surveillance. We can also consider obfuscation methods, such as loyalty card swapping, in the same manner, where intentional behavioral change is done in order to garble data. Another mode of resistance is sabotage. This is where subjects destroy or disable the means of surveillance. We do see it playing out usually in cases of state surveillance. I think we can consider sabotage as a final mode of resistance when all other options have been exhausted. So we can put these into a matrix with one dimension as automutative or self-changing, and exomutative or external changing, and another dimension as corporate and state surveillance. Now I split corporate and state surveillance not because these necessarily capture the exact differences, but I think that there tends to be a different set of resistance possibilities when we're talking about corporate and state surveillance. And the point of putting this into a matrix is to identify what we think is an underexplored region of the design space. So in the case of state surveillance, the state owns and operates the means of surveillance. And so a subject-only mode of resistance, if they wish to change the system itself, tends to be sabotage. Looking back at the anatomy of an AI system, it's actually the subjects of surveillance who own and operate the means of surveillance. So if we can counteract this knowledge asymmetry in the system of surveillance, we can design to disrupt not only our own behaviors, but other aspects of the surveillance system. So I'm going to go into a demo now. So this is the app. It should look fairly familiar to anyone who's used a standard mobile camera application. Capture buttons in the center. We can see that we're processing images, and then the gallery appears on the right-hand side. And on the left-hand side, we can flip between front and rear cameras. Hey. And so what I'm going to do now is just take some photographs of things on my desk that I happen to know are part of the possible ImageNet labels. My microphone and this birthday candle. And so when we open the gallery view, what we'll see is both the images itself and also an indication of what a standard machine learning model can actually see in this image. And by dragging this slider at the bottom, we can actually increase the perturbation of the image to the point that the image is no longer that the network can no longer make sense of these images. For something like this computer keyboard, it actually turns out to be a bit harder to get to that level. And And so we actually have to increase the level of perturbation, perhaps beyond what a user might be happy with. And so we can drag this all the way up to essentially full and get an extremely noisy image. But really, the point of this slider is to allow a user to make a decision as to how much perturbation, how much noise they're willing to accept in their images in order to increase the likelihood that they can avoid surveillance. Now, all of these perturbed images in their kind of noisy form are available to the rest of the phone, such that they can be backed up on a cloud service or posted to a social media site, and hopefully, when they get passed through a computer vision system, they're a bit harder to interpret. So how does this work? Camera Adversaria adopts a set of practices developed by the deep learning research community called Adversarial Perturbations. So to return to that model of image classification, an adversarial perturbation is a specifically designed set of pixel values that can be added to an image such that the computer vision system confidently misclassifies the image. This property of convolutional neural networks was discovered in 2014, and since then it's become a significant subdiscipline in deep learning research. In around 2017, it was discovered that universal adversarial perturbations were possible. So that's a single filter that can be applied to any image that causes the machine vision system to misclassify in a significant number of cases. Most adversarial perturbations are computed as an optimization problem with the network, but this paper by Ko et al. Showed that it's possible to generate universal adversarial perturbations with just procedural noise. This is an ideal approach for resisting surveillance because the adversarial perturbation can be computed cheaply and uniquely for each image. The initial idea was for an online service that would perturb people's images. We soon realized that transmitting users' photographs to a foreign server would introduce so many trust issues so as to defeat the purpose. In addition, as we've discussed, these deep learning systems are being applied in the camera app itself. And so it became clear that we would have to introduce our adversarial perturbations at the source. And so that meant creating a camera app. So aside from designing the adversarial filter, this application isn't particularly complicated. And so this raises the question, why hasn't anyone done this before? Lots of other deep learning research has been quickly turned into free online services, Deep Dream, Pix2Pix, GANs, that kind of thing. But nowhere we've discovered has anyone in the adversarial perturbation research community attempted to make adversarial methods available to subjects of surveillance. And this includes some researchers who developed a mobile app purely to demonstrate their methods. To understand why, we need to look at the language of the research community. In deep learning literature, adversarial perturbations are described in the language of threats, exploits, and bad actors. Deep learning systems are presumed to be good, or at least neutral, and those wishing to disrupt it are malicious. And the literature is full of value-laden language. These are just some examples from the work that we've read. Machine learning classifiers are known to be vulnerable to inputs maliciously constructed by adversaries to force misclassification. This linear behavior suggests that cheap analytical perturbations of a linear model should damage neural networks. Know your adversary. If you know your enemy and know yourself, you need not fear the result of 100 battles. And even the paper whose approach we modeled our filter design on says it is important to ensure that such algorithms are robust to malicious adversaries. So I want to state just for the record that adversarial perturbations are entirely non-destructive. This is not a form of sabotage. They confound a machine vision system only within the scope of that particular image. So I think this raises a really important question about the role that the research community plays in countenancing these systems of surveillance. And so part of the critical work of Camera Adversaria is to extract these methods out of a literature that describes them as malicious and offensive, and really reclaim it as a mode of defense against surveillance. To return briefly to Dunn and Rabi, we find in their initial work on critical design this significant point on ideology. Most design affirms the status quo, reinforcing cultural, social, technical, and economic expectations. And clearly, I think the same thing is happening in the research community. We are building tools of surveillance entirely uncritically and maligning any attempts to get around the system. Now, one significant limitation of Camera Adversaria is that it's just a stopgap. It's fair to expect that computer vision algorithms are going to improve and probably become less susceptible to adversarial perturbations. And while it's fair to assume that adversarial methods will also improve, the point of this project is not to start an arms race. And so the point of Camera Adversaria instead is to reveal to some degree the surveillance system and present an alternative. Thanks for listening.